get started. Given that there is not, given that there's not a lot of people, like, so I think we can be more interactive. So like, feel free to unmute yourself and ask questions or answer in between. Okay, so this tutorial is going to be a bit different from the tutorials that we have seen so far. Okay, so like today we are going to talk about, well, this is more of tips and like general ideas about like how to write good reproducible code, right? Like so the general topic that we are going to discuss today is like how to write good and reproducible ML code. Okay, now maybe why don't we start with a question? So can somebody tell me, why should we care about reproducibility? Okay, do people hear me? Like, so I think you can unmute yourself and answer.
Hello, can you guys hear me?
Yeah.
Yeah. So I was just wondering, what exactly do you mean by a reproducible code? Is it code that's gonna, consistently give the same score for like the test set, different test sets?
Oh, not for different test set. Like, so if I run the same experiment once again, I should be able to get the same performance. Okay, maybe it was not very clear. So let me try to explain a bit more. Okay, now, if you think about traditional software programs, right? Like, so, like, let's say you implement a data structure, or like you implement like any functionality for a software, right? Like, so now these programs are going to behave exactly same every time you're running them, right? Like, so like you have an implementation of, let's say, red black trees, and like you give a sequence of numbers. Every time you give the same sequence of number, the algorithm is going to give you exact tree, right? Like, so in some sense, things are deterministic, like in execution. So however, like with machine learning programs, right? Like, so now we know that there's a lot of stochasticity involved, right? So can someone tell me what are the sources of randomness or stochasticity that we could see in a machine learning program based on your assignments? Anyone?
Well, personally, I know that when I was running my grid search for the last assignment, sometimes I got different results, like for the best parameters in the end, but I wasn't able to understand why.
Okay, so when you run these experiments, you get different results sometimes. Like, why is that happening? Anyone else? Okay, so now let's take, okay, so there are some answers in the chat. So the outcome is some randomness, like yes, but let us try to understand what are all the different sources of randomness in your program, right? Like, so now let's take neural network as an example. Okay, now I want to train a neural network. which is something like this. Just a one layer neural network, like where you have some parameters W and V that you want to train. Okay, now this is an example of a nonlinear model, right? Which means you cannot reach the global optimum like when you're training. So you're going to get stuck in a local optimum. Now, the way in which we start doing our gradient descent is by having a random initialization for W and V, right? So that is the first source of randomness. Like, so when you have random initialization of the parameters, now every time you run your program, you're going to get different initialization. Now, some initializations might be good initializations, some might be bad, some might be similar but slightly a little bit different, right? Like, so this is one of the sources or reasons why every time you run your neural network code, like, so it is going to give you slightly different performance. Like maybe one time it was 70% validation accuracy. Next time it might be 68%. Next time it might be 71%. Okay. Now, one reason could be the randomness in the initialization of the parameters. Now, what are the other reasons of randomness that you can think of? Anybody? So initialization is one thing. Like, so what are the other sources of randomness? So think about what are all the places where you're using some notion of probability, right? Like whenever you do some sampling, it creates randomness. Like, so in the case of initialization, you're sampling your initial weights from some distribution, like maybe a uniform distribution or a Gaussian distribution, and that creates randomness. So what are the other sources? Now imagine you're doing mini batch gradient descent. Okay, so in which case your data iterator, which goes through the entire data set, might have some randomness, right? Like, so now let's take MNIST as an example. Like, so in the case of MNIST, you have a training set which has 50,000 examples. Now, let's say I train a neural network with a mini batch size of 100. Okay, now this means I should randomly shuffle the data set and pick batches of 100, right? Like, so now every time I run my experiment, I'm going to get different shuffling. And this is also going to cause randomness in my performance. Okay, now this is the second reason. And there are a few other reasons. Like, so for example, like if you have any sort of sampling or probabilistic layers in your model itself, okay, that could lead to randomness. Is that clear? Now let's go back to our reproducibility question. So now, because of these various reasons, like say every time I run my experiment, I don't get the same performance. Okay. Now, let's say you work on a research problem and you get 78% performance, let's say, which is a state-of-the-art number. Now you're publishing these results. How can others trust your code and your result if they cannot reproduce it, right? Like, so by reproducing, I mean someone else should be able to implement. Forget about implementing your algorithm. Someone else should be able to take your own code and run that code and get the same performance. Okay, that's the simplest reproducibility. But even harder reproducibility is like someone else should be able to implement what you implemented by themselves and get the same performance. So that is even more challenging. But let's talk about just taking your code and running it again to get the same performance, right? Like, so now why is that important? Anyone? Okay, everyone is silent.
Well, depending maybe on the nature of what, like say the model is like a classifier. So depending on the nature of what the model is trying to classify, it may be, more or less important to get correct results.
Yes. Yes, we need, yes, that is one reason. Any other reason? In general, I think like verifying the correctness of claim. And there is also another reason, like, which is just doing good science. Like, you want to build trustable programs so that others can build on top of it, and create more and more complex systems, right? Now, there is also another practical reason why reproducibility is like interesting or needed, which is for resuming or resumability of your experiments. Okay, now what do I mean by that? So some of you might have used clusters to run your experiments, right? Like, so if you use a cluster, then typically clusters have queues, and like you have limited wall times. Like maybe you cannot run a job for more than 12 hours. Now imagine you have an experiment which has to go for 3 days. Okay. Now, if you have a limited wall time of 12 hours, which means your job is going to get killed at 12th hour, right? So now your job is running and it gets killed here. Now you should be able to perfectly resume this experiment so that you can save time and continue training your model, right? Like, so now this is not possible if your code is not reproducible. Like, or in other words, like, it is not possible if you don't control every source of randomness and checkpoint things on the way, right? So typically, like, let's say you are doing stochastic gradient descent. Like, so after every epoch, you will be checkpointing your model. Okay. Now, let's say after a bunch of epochs, now in the middle of this epoch, like your job got killed. Now you can actually go back to this checkpoint and start training a new run starting from that epoch. Okay. Now, if you don't have, like, if you don't keep track of the sources of randomness, then you might have a slightly different experiment every time your job gets killed. Okay, now again, this is not helping us with the reproducibility. So it is important that your code is perfectly resumable so that you get consistent result. Is that clear? Any question? Yeah.
Yeah, I just have a question. When you say that, you save a checkpoint, does that mean you just save like the parameters?
Okay, but that is a good question. Now, I'll ask that question to you all. Like, so now, again, let's take a specific example. Okay, so let's say I am using neural network as an example again. Okay, so I have a neural network and I have a data iterator which has the MNIST data. Okay, and we haven't seen advanced optimization methods yet, like, but next week we are going to see that. But let's say I use an optimization method like SGD, but with momentum. Okay, which means it's an optimizer which has its own parameters, like the momentum parameters. Now, what are all the things that you should checkpoint so that you can perfectly resume, right? So Now, the first thing that you should checkpoint is definitely the parameters of the model. Okay. Now you should also checkpoint the parameters, if any, of the optimizer. Okay. And you should also checkpoint the state of the data iterator. Because every time you shuffle your data, you're shuffling it with a random number generator. Well, you should store the state of the random number generation so that like next time when you resume from a checkpoint, you resume from exactly same part of your gradient descent. Is that clear? Any question? Okay, so now I think we are talking about two things here in parallel, right? Like, so one is controlling the sources of randomness, and the other is checkpointing. So my general tip, if you are working on a machine learning project, is to first set up your initial pipeline. Okay. Now this pipeline in the pipeline, you should make sure that every source of randomness is controlled and there is a proper checkpointing function, which whenever you call will checkpoint the whole program. And you should also have this resuming function, like which will take a checkpoint and resume from there exactly. So is that clear? Any questions so far? Okay, well, we don't have a lot of topics to discuss today, so I was hoping that it will be more interactive. Well, maybe I should have mentioned previously that this is an interactive tutorial, because probably normally people are joining from what places without audio.
Well, I think a lot of people, like the end of the semester is, very near, and we all have plenty of like other classes, other assignments. And like I know I have some friends who are like who really wanted to come, but they just have too much work in other classes.
Yeah, I understand that. I understand that. So that's fine. We will share the recording. Okay. Okay, so well, also probably we will finish like shorter than 1 hour. So like, so this is mostly tips for how to put your machine learning projects. Okay, so now I'll probably like write the higher level pipeline, okay, so that it is useful for you like when you structure your machine learning projects. Now, normally you will have your model component, okay, so which would have prediction function, like update function, which might use gradient descent for update. Or if you're using a simple model like linear regression, like maybe you have a closed form fit function and so on, right? So you'll have a model class and you'll have the optimizer class. Okay, and you will also have the data iterator class. So you should make sure that all three of them actually have checkpoint function, resume function. So this is for checkpointing. Now for controlling the sources of randomness, like you should have a separate random number generator. for each of these classes. Okay, so for example, let's say you have a random number generator to generate the parameters, like initialization for the parameters. Okay, so can someone tell me what would happen if you use the same random number generator for both model and the data iterator? So what could be the risk in using the same random number generator for both model and the data iterator?
Well, I'm not really sure, but maybe I can try and answer. So I know like in C, like on microcontrollers, like when we call like a random function, it's not truly random. It's more like a pseudo-random. So like when we would start the code again, we would have the same numbers generated in the same order every single time. So if we have, you know, a random number generator for each of the functions, then like each of the numbers would be the same for each of like yeah, exactly, for each of the different classes. And they would
Okay.
stay in sync that way.
Well, so that's a good point. In fact, when I say we are controlling the sources of random number, right? Like, so that is exactly based on this principle of pseudo-random generators, right? Like pseudo-random generators, like so. Like random numbers are not exactly random, like so they are generated based on some algorithm behind, right? Like so. So if you call the same thing every time you initialize, you're going to get the same sequence of random numbers. So that is how we are controlling the sources of randomness. Now think about this, like, so let's say I have a model which has 100 parameters and a data set which has 10 data points. Okay. Now I want to initialize these 100 parameters. I want a shuffling index for all these 110 data iterators, which means totally I need 110 random numbers, right? Now, if I use the same random number generator to generate all these 110 random numbers, it's kind of okay as long as I'm repeating the same experiment. But let us say I want to try different models without affecting the data. Okay. Now I'm trying to increase the capacity of the model to see what happens. So like what if I use 200 parameters instead of 100 parameters, right? So in that case, if I'm using the same random number generator, then the problem is, yeah, I'm using the first 200 of those random numbers for the model. So the shuffling that I'm going to get for the data is going to be different than the shuffling that I would have got if there was only 100 parameters. Is that clear? So it's important that you kind of disentangle or like have separate random numbers for both model and the data iterator. And the same goes for optimizer. Like, well, I think for optimizers, we don't have a lot of sources of randomness. So probably you don't need a random number generator for the optimizer. Okay, so now I think what? So this is mostly what I wanted to say. I was hoping that we'll have more conversation, but like if there, I can take questions. Like if there are any questions in general about how to write good machine learning code or how to structure your code, like I would be happy to answer now.
Well, I didn't quite understand the usefulness of the random number generator. If you could, you know, please just maybe explain it again, that'd be great.
Okay. I think I lost my Zoom. Sorry, just give me 1 second. Okay, it's working now. Yeah, so can you repeat the question, please?
Yeah, maybe if you could please just explain again why the random number generator is useful. Like I get it's that we want to keep like the randomness sort of like equal if you want to change the model, but other than that, I'm not sure I understand like on a deeper level why is it useful?
Well, first of all, like we want consistent results, right? Like so, like every time if your result changes, like then what is the guarantee that if you say that your model is getting 80% performance, it is really getting 80% performance, right? So for the consistency, you need to use the same random number generator every time. So let's say you run an experiment today, you get 80% performance. Now you want the same performance if you run the same code even after a week or a month, right? Now, one way to guarantee that is like by setting your random number generators with a seed. Let's say you set a seed of 5. Now, every time Python's random number generator is starting its random number, since if you give the same seed, it is going to start generate same set of random numbers. So this way you can actually control the performance, like consistency of your model's performance.
All right, thank you. I understand better.
Okay. Okay, so there's a question in the chat. Any great resource, book suggestions for MLDS code? Okay, that's well, I am not aware of any book for how to write clean ML code, but there is a lot of resources available for like machine learning programming with PyTorch or machine learning programming with TensorFlow and so on. But those are not about how to write good code. So maybe I will do I'll do a little bit of more search on how to write good machine learning code. And if we find any good resources, like I will share that with the class. I can also quickly check. Okay, I should. Okay, so I think it is hard to find. I will find something and share it with you guys. Okay, so any other questions?
Well, it's not really a question like on the topics we discussed today, but would you mind sharing a bit, some of the projects you're working on in your lab?
Yes, sure. So, oh, that question gives me an idea for the previous question. So just give me 1 second. So I would call it's like an ad or a plug. So like I encourage you guys to look at some of the public repositories that we have in my lab. I like most of them. Like so in my team, like we have an internal like strict code reviews and regulations policy, like even for like research code. So the code that we release is usually like very high quality. So it's something for you to look at if you want examples for good code. And coming back to your question about the kind of things that I work on my lab, like so Well, I work in several areas in machine learning, it includes deep learning, reinforcement learning, natural language processing, and also lifelong learning. So the general idea, or theme that my lab is focusing on is like, how can we design interactive learning algorithms that can continuously learn through experience? Okay, so now if you think about the kind of algorithms that we have seen so far in this course, right? So they are not that interactive. Like, you give me a data set, I train the data set, I train a model using the data set, right? Now, humans don't learn by just reading a lot of examples, right? So we learn a lot by interaction, which is also captured in reinforcement learning, but I don't mean just reinforcement learning when I say interaction. Think about having a smarter Siri, which would talk to you and understand you well and pick up new skills from you and do tasks for you, right? So now that is the kind of interactive systems that we are aiming for. Plus we also do a lot of work in more fundamental machine learning topics, like, for example, recurrent neural networks, transformers, dialogue systems, and so on. So I think if you are more interested in the kind of research that we do, you can check our publications in the lab website. So that will give you an idea of the topics that we are currently working on.
All right, thank you very much.
Okay, well, then probably we can finish earlier and save this time for your Kaggle competition.